All right. Good morning, folks. Welcome to circuitry lesson number 2 of 3 here today. And we are talking about voltage. My name is Mr. Blake. And our lesson yesterday, our concepts were circuit. So a circuit is a pathway through which electricity can flow. Now today, we're going to talk about that electricity. We're going to talk about voltage. So what is voltage? Voltage is just the difference in electric charge between 2 points. So we talked about yesterday, or rather last week, the battery. So when we have 2 points right here, and we connect them with a pipe, say we have a bunch of electricity in here and none in here, okay? When we connect those two spaces with a pipe, electricity will what? Flow through here. Just like we talk about water flowing and water doing work, we can get flowing electricity to also do work. So a battery is basically a container with a big wall in the middle. Nothing goes through the wall. And in two sections, we have a space with a bunch of electricity and a space with none or low amount. And our circuit involves connecting a pipe like this. So now what we have is the electricity flows out the one side through the circuit and to the other side of the battery. Now, how long do you guys think the electricity will flow like this? What do you guys think? Do you have an idea about that? Does somebody want to chime in, perhaps?
Well, probably it means how fast it's going
Sure.
will.
How fast it's going will definitely be a factor, but
Until it equalizes?
until it equalizes, right? Until we have, instead of 8 and 0, we have, I still need a proper eraser, 4 and 4, right?
Yeah.
So we're not going to have all of it go over here and have 0 and 8, right? It's going to go until it can't go anymore. And until it can't go anymore means when they're the same, okay? So when we have a dead battery, that's essentially what we've got. We've got both sides of the battery are the same electric charge. And when we go and charge a battery, what are we doing? We're putting more electricity into the one side where it needs to go, and we're taking it out of the empty side where it needs to not be, okay? So today, we are going to work on a project, and we are going to answer the question, how much voltage is necessary to light an LED? So when we talk about electricity flowing like water, if the water isn't strong enough to push whatever it needs to push, like say a water wheel, then it's not going to turn the wheel, right? If it's too weak. So the strength of that is basically what our voltage is. So now we're going to cut over to the other project camera on the workbench here, and we are going to check some stuff out. And I'll move into speaker view, spotlight my video, and move over to the other camera. Alrighty. So what we have here is a light connected to a battery. Now, obviously, this battery still has enough voltage that it can light the light. Let's go ahead and see what battery voltage we have here. Now we can do, let's take off the light just to sort of make it easier to look at. We can do one thing, and that is look on the battery itself. It actually has writing on it. It's really hard for you guys to see on the camera perhaps, but it is there. And on the writing, it says CR2032. This right here, that's the type of battery, the size and all that it is. But it also says 3V. 3V. That stands for 3 volts. Okay, so this battery is a 3-volt battery. Now, let's see what the voltage is right now, because actually, I left this light on the battery overnight for a long, long time. And the light itself is a very small pipe. So only a little amount of electricity flows, which means that the battery is going to last quite a long time and take a long time to drain. But let's go ahead and look at how low it is. When I measured it yesterday, doing the lesson yesterday, we saw that it was at about 2.8 volts. So we know from that 2.8 volts is sufficient to light the light. Now, what we're going to use to measure it is called a multimeter right here. Pretty inventive name, huh? It's called a multimeter because it does multiple things. So that's pretty easy to remember. Now, the multimeter itself, if we look at it, we see that it has these sections like this here, this here, this, and this. Each of these sections is going to measure the electricity in different ways. We are interested in discovering what the voltage is here. So we want our meter to measure voltage. So to make sure that it's measuring voltage, we go ahead and we make sure we're in the section that says V for voltage. Now, if we measure something at, say, 2 volts versus measuring something at 200 volts, that's drastically different. And we need to make sure that our meter is set to be able to measure the proper range of voltage, okay? In the voltage area, we see 200 M, that's 200 millivolts, then 2, then 20, then 200, then 1000. So since our voltage is going to be within the range of between 1 and 10, we want to make sure that we have the proper range selected. So this little knobby can turn to measure all kinds of things. Let's turn it back to the voltage area and make sure the specific range that we have selected says 20. We want to be measuring between 1 and 10 volts. So we need 2 decimal points here after, or to the left of the decimal. So we're going to go ahead and put the probes into the meter. We have a black probe for the black negative side of the voltage, and then we have the red probe for the plus side. Okay, whoa, things are kind of mirrored. So let's measure our batteries, okay? Let's see how we do. We've got a whole bunch of batteries here. In fact, have you guys seen a 9-volt battery before? Sure you have. It's called a 9-volt battery specifically because it's supposed to have 9 volts when it is new and working. So we're going to go ahead and touch our probes to the head of this battery and see what voltage it actually is at. Now we can look at the battery. We see a plus side over here. So that tells us that this terminal is the plus terminal. So we want to make sure that's the case. Our red is our plus. So when we touch the battery, we see this battery is at 3.08 volts. Now, given a 9-volt battery, that's pretty low. That's a third of what it should be when it's new. So whatever this battery was in before that required just under 9 volts to work, or 9 volts, is not going to work if we only give it these 3 volts. So this battery is not completely drained. It's not zero, but it's certainly not going to be useful for anything that a 9-volt battery needs to go into. Now, let's set that aside for now. And let's measure some other dead battery. I have a Duracell battery here. This is a AA battery. Now, I can look at the battery, and its little text again is going to tell me what voltage it should be when it's new. So I see that. I look at that. I see 1.5 V. It's right there. You have to trust me because you can't read it with the camera. But 1.5 volts is what this battery should be when it's new. Let's go ahead and touch it with our multimeter to discover what it has right now. Now the smooth side is going to be our minus side, and the side with the bump is going to be our plus side. So we touch that and we see 1.29. Okay. Now the question I have for you guys here is, do you think 1.29 volts is going to be strong enough to light our light? As we use our 3-volt battery and deplete it and it gets lower and lower, how low do you think it's going to get before it no longer lights the light? Do we have any thoughts about that? Who thinks that perhaps it's going to get down to 2.5? Maybe. Who thinks it's going to get lower than 2.0? Do we think that lower than 2.0 will be able to have the battery go on, or have the battery light the light? We'll have to see about that. What we have right here, in fact, is a battery that gives us 1.29. So let's try to hook up a light to this battery and see if it goes on. Now, we also have a bunch of other batteries here. Let's go ahead and use those later and see what else we can do. So let's put these all aside for right now. And let's go ahead and prepare a little circuit for our light. I'm going to use some scissors here, and I'm just going to cut off a square of paper. You can see I've already cut this paper, but I'm going to cut off a similar square of paper. So to get our battery, or to try to get our battery to light this light, we need to make a circuit. Okay, the circuit that I'm going to make with you guys here is going to look like this. We're going to come out of, let me go ahead and mark the plus and minus sides of the battery. The plus side over here and the minus side over here. We're going to come out of the battery. See if I can use my left hand. Come out that side, come up here, go there, and then the break for our LED, we come this way, down, and back into the battery. So this is our little circuit that we're going to make today to see if 1.29 volts is sufficient to light our battery. Okay, we have our tape. We're going to rip off little sections. That one for right there. That one for right there. Whoop. Come on. Oh my goodness, wants to roll over. There we go, put that down there. These little sections for here and here as well. And then of course, to get our LED down, we're going to go ahead and make those segments there. Now I'm going to start by putting my LED down onto there, and I'm going to go ahead and look in this box and get myself one of these LEDs. Now I'm not going to open the lid all the way, because actually on the inside of this box is a sticker that actually tells me exactly what voltage is required for each of these lights to go on. So I'm not going to show you guys that because we're trying to figure that out. Let me go ahead and grab a red LED. Okay. I'll show you that sticker at the end of this lesson, you guys, so you can see. Now remember, LED has a long leg and a short leg, and we need to make sure that our long leg is the one that touches the plus side. Okay, so let's make sure that's the case. I'm going to bend out my long leg here, and I'm going to get it under the tape right here. So let's start with that. Let's get our plus side leg taped down. I did just cut my fingernails last night or the night before, so this is a little difficult for me. Wow, I got really lucky there. All right, let's get this down on this side and put that there. It's fine that it's a little bit longer than we thought. I'm going to get this other piece right here, and I'm going to get the other leg down. This is the minus side leg. We got this tape going down on there. So our LED is down. Let's go ahead and put down these other sections as well. Oh, come on. Peel that away. A reminder that this is pretty difficult to get this peeled off here, but just takes a little bit of patience. There we go. Got it. And it does curl up, so you want to be very careful. Certainly don't take off super long sections at a time. Kind of restrict yourself to these smaller segments. You don't have to exactly follow the line and cover it. That's just kind of a little bit of a map, a suggestion, but here we go. So this right here, we have to make sure that the joints at each of these corners overlap as well, because we want a continuous pathway. We don't want to break the continuity of the pathway. So let's go ahead and get the other side down, and we will see how this works, or if it works. Okay, oh my goodness. There we go. All right, so put that down, and then the last little segment here, we have that. All right, so our battery, our circuit, that side touches there, okay? And then this side, we can fold it over and touch there. Do we see that light going on? No, we do not have a light going on. Now, maybe our circuit's broken. Maybe that's not continuity. Maybe it's not working because it's not getting the voltage. It sure looks like it's going the correct way. Let's confirm that it is. Okay, so what we're going to do is we're going to attach our multimeter to our circuit and measure this voltage. Okay, so yeah, this way. There we go. To do that, I'm going to use 2 more little bits of this copper tape here. Okay, so I'm going to rip off kind of good sized sections, you know, an inch long maybe at least. And using those sections, I'm going to tape my probes down onto my circuit. Now let's see how that goes. This one can maybe go like that there. Let's get that on there to confirm that we are in fact connecting our battery correctly on there. So it's okay if we sort of do an angle like this. We just want to make sure that it oh, I ripped the tape. I'm going to do another one. That's not good. Well, it actually is connecting the end here with right here, but it's not connected on the other side. I think that's going to be perhaps enough. No, let's go ahead and make sure that it's connected all the way across. All right, so I put another piece of tape there. All right, so that is on there now. Let's go ahead and get another inch long segment here. Let's get our positive probe and bring it over here like this. And let's see how this looks now. So we get this on here and we put the tape down. It's okay that it kind of goes up over here. It's not really a problem. All right, now what we should do when we pinch this together, what we should see is 1.29 volts appearing on our multimeter. Look at that. So this battery It's all connected correctly with 1.29 volts, and we do not have a light going on. Now I have another bunch of batteries here. Let's go ahead and say, try this one. What level do we think this is at? Let's see. Oh my, this battery is significantly hotter. 1.49, that's almost brand new, almost 1.5. But we see that 1.5 or 1.49 rather does not turn on the battery. So now the battery that I had at the beginning, you guys, this coin cell, this was connected to a light overnight for quite a long time. So this means that it should be quite depleted. Now let's go ahead and measure it. We know that it's able to turn the light on. So I'm going to pull my probe ends out of my little circuit here, and we are going to touch the sides of this battery and see what we get. It says minus 273. Now it says minus because I have my plus on the minus side and the minus on the plus side, and it's backwards. So I'm going to switch that. I'm going to bring this here, and I'm going to bring the red one down here. All right, 2.74. Okay, 2.74 is still sufficient to turn the light on. So we didn't really find the exact voltage that's necessary, but what I'm going to do is I'm going to leave this on here for a long time until it goes off. And then when it goes off, then we will have found that it's not sufficient to light the light anymore. What I could do is I could just take a wire and connect one side of the battery to the other and drain it a whole bunch and then see if it still is able to light the light. All right, so that's our lesson for today. Next week's lesson, lesson number 3, is going to be about current, which is how big a pipe are we talking about? How much electricity can flow at once? Now the light, the LED we talked about, is a very small pipe. Only a very small amount of electricity flows through it. And it would take a long time for me, in fact, to deplete this battery by just letting that sit on there. So yeah, that's our lesson for today. Hopefully you guys will tune in next week. Oh, we have a visitor. Excuse me, Tyrion. Hopefully you guys will tune in next week and go over the lesson involving current. And thanks for joining me here today. Have a nice day, folks, and hope to see you next week. Bye-bye.